Hi everyone, my name is Tao Yu. So today I'm going to give the presentation about empowering MBSE with Cynefin to systematically handle the uncertainty for the first uncertainty modeling workshop at Models 2020. So this is the work has been done with my colleague Shaukat. So nowadays, we're actually having the massive high-dimensional, low-quality multimodal data. So we see the data of noise in data, high dimensionality, and also the such intelligent system and operating from fixed environment to dynamic and more open environment. As we see from what happened actually in the last few years is that external uncertainty and the internal uncertainty seriously affect the reliability of intelligent system. This motivates us to actually think that how can we systematically dealing with the uncertainty in the context of model-based system engineering. So from literature, we see that the paper published in 2013 about deep uncertainty classified the uncertainty into 5 different levels. So we see here the from top to down is going from the shallow to deep. So in this paper, actually, we try to fit this classification into our framework as well. So for the shallow one, for example, we have a clear enough feature of the single system model, and all the way to the deep one is that we are facing an unknown feature, for example. So, the challenges to handling uncertainty nowadays we're in the modeling community is that existing solutions are for addressing the shallow uncertainties in known and knowable spaces, but careless about system operating in increasingly uncertain, unpredictable, open, and networked environments. So this motivates us to actually think about whether this famous Cynefin framework that has been used in the management organization management domain can be useful somehow to handling uncertainty, different kinds of uncertainty in the modeling community, MBA and MBSE. So we see this sketch offered by anyone Stoop about the Cynefin framework. There are actually different aspects. So we go from this simple situation to complicated situation, and then transit to the complex situation and to the chaos situations. And in this Cynefin framework, and they actually recommend the practice to handle the different situations. For example, for the simple situation is like 1 + 1 = 2, so you have the best practice to follow. And for complicated situation, you have good practice. There are multiple choices, but the domain expert is able to decide which is the best choice for organization or for specific situations. So we will discuss the other 2 more complicated deep uncertainty categories like complex and chaos later with examples. So the simple, as we said, it's very mechanical. It's predictable, and the cause and effect understood, and as said, predictable. So the examples like you're following predefined procedures, so there's no surprise. So recommend the best practice is to try to sense what's going on and then do the categorize and then respond accordingly. So. And for the complicated situation, but still it's the space is knowable space, so you need some effort to actually to predict what is going to happen, and also the cause and effect can be determined with sufficient data, right? So for example, we're developing the technical solutions to technical challenges. For example, we're analyzing the data. So then for this, you have to take recommended to actually in the organization management, the recommend to sense the situation, you analyze the situation, then you respond. So always you actually have a good practice to follow. But for the unknown space, which is a complex situation, for example, in this case, is not predictable. What is happening? Future is not predictable. Cause and effect may be determined after the event. For example, building trust, you leading cultural change, and some really innovation projects, managing that. So then the thing is that is the one sentence here I think is quite important. It's not just it's just because one of the many predictions was right doesn't make it predictable. So then we might not be able to rely on the data we had before, which we call historic data, to help us to make decisions in a complex situation. Then you need an emergent practice for this situation. Chaotic is unknowable space, which according to the Cynefin framework, so the cause and effect is not discernible, and you need a novel and creative approach to handle it. So usually it is recommended you take action, so get after the emergency, and then you try to sense what's going on, and then you translate it to the other context, for example, the complex or even simple or complicated situations, and then we see what happens. So it's more like an iterative process, but first of all, you jump out of the danger. So this is the basic Cynefin framework. It actually has been practiced in very diverse contexts for improved decision making in the domain of economics and facilitate system thinking in the organization management. Also understanding the complexity of issues has been used. They have been used to identify appropriate strategy in health promotion. So Cynefin has also been explored in the past in software engineering to support process management, for example, as a research tool for identifying issues, and also the French. Some French actually use the Cynefin to reflect on the processes of the uncertainty modeling analysis in statistical risk and decision analysis. So below is a reference to the paper actually published by French. So in this paper, we actually try to use our way to actually enrich the Cynefin framework and bring the 5 levels of from shallow to deep uncertainties into the Cynefin framework. Therefore, actually we propose this conceptual model here. So we see that we have a concept is uncertainty chapter here, and we see here we have the classification, 5 levels classification of uncertainty. And then this uncertainty is eventually contributes to the complexity of the environment and the system. And MBE methodology is actually used to facilitate the development of such complex systems. So Cynefin framework itself actually have different action modes we discussed before. These are the 5 patterns according to the different contexts discussed in the actually Cynefin framework, and also have the practice recommended in Cynefin framework. So this is a conceptual model that we bring the uncertainties together with the Cynefin framework. The purpose of bridging the MBSE with the Cynefin is to understand, first of all, to understand the complexity and construct the models. So the complexity we all understand. I think I skipped this. So then we go say that they actually have different kinds of uncertainty. So first one is the cognitive uncertainty. So it talks about how well people actually perceive things, right? So you need effort of doing that. Objective complexity exists in both in the system study and also in its environment. So this is typically we see actually when we develop the systems. So, but understanding objective complexity, it also requires a cognitive effort by a human being, especially for us, for example, modelers, right? Because she or he needs to construct the models. So the Cynefin can be used in MBSE to support complex modeling activities. For example, modeling uncertainty, the behavior of a system, and its environment. So we actually foresee. So we think that we can actually somehow identify the Cynefin contexts and support the model evolutions. So Cynefin actually can be implemented in a complex system such as autonomous driving. So the autonomous driving cars can actually automatically identify different kinds of context, Cynefin context, and make decisions accordingly, right? So we see that is one of the possibilities how this Cynefin framework can be useful for us. So we actually developed a very initial, idea in this UML class diagram. I actually try to see that, um, decision making and system evolution, even the MBE methodology itself evolution, and even uncertainty itself the evolution. For example, going from the shallow uncertainty, deep uncertainty to shallow uncertainty, and how all these things can be actually supported with the Cynefin framework. So the other details actually are provided in the paper. So uncertainty modeling and analysis part is that, and the state of art shows that we actually lack of works to specify or model the deep uncertainty. We also lack the classification on different types of uncertainty. Even though we are making an effort, even we are actually working on a standard for precise semantics for uncertainty modeling, but still the deep uncertainty is actually very hard to deal with. Another thing is supporting the evolution and discovery of the previously unknown uncertainties. So we think that in this direction, there still have some opportunities to actually that the Cynefin framework can somehow help us. Regarding supporting the decision making on the deep uncertainties, we see that MBSE methodologies that implement the Cynefin need to be provided the capability of dealing with deep uncertainties in response to unpredictable evolving situations of a system under study. Analytical tools such as exploratory modeling and scenario discovery has been recognized to be effective, but more empirical studies are required to see how that can be actually integrated with the existing modeling solutions. We actually, our students actually did initial validation of the Cynefin framework in the context of self-driving scenarios. Actually, I think due to the time constraints, so I will briefly discuss some of the exercise our student has done. She actually tried to actually identify the self-driving cars, the scenario, different kinds of scenarios from literature, and try to actually use in the Cynefin framework to classify them, right? So we see that, for example, if one car is on the road and there's no other agents around, so this is a simple situation. Also, you see that there are several agents with right behavior around, so there's no abnormal behaviors. So in this situation, there are best practice, right? So we can all see that. So for a little bit more complicated scenarios, that we see that someone is actually crossing the road, and we have the car here, and they actually try to make a turn, right? And also you want to actually have a lane merge, and then have a change in lane. But this kind of behavior is actually predictable. But you need to make some effort, and also need some expertise to make an effort. Decision. So the cause and effect can be determined with the sufficient data in this situation. So then we sense, we analyze, and we respond. I mean, we here means that this autonomous driving car. So if you go the more complex situation, here is safe distance here, So the distance between two cars is actually greater than the predefined, the safe distance between two cars, right? And also have the situation that the car is actually in the intersection, actually without the traffic lights. So then this situation is that because you have no control of the other cars, so the behavior of the other cars is really unpredictable. So that's part of the environment. So the cause and the effect may be determined after the event, after some time, and you observe continuously observe what's going on in the environment. So in these situations, you might want to actually take the actions of like probe and sense and then respond. So in this situation, for agent here, you need to follow kind of emergent situations. So we come to this chaotic situations is that the distance of two cars is already less than the safety distance predefined. And also you have a situation, traffic lights lining like this, there's a red light and there's cars trying to pass. So this situation is that is really a chaotic situation, and then the only thing you have to actually is quite danger, right? So there's a safety concern. So you might need to take an action, for example, brake, or you for this car maybe turn right if everything is safe, and then sense and respond. So this is kind of initial understanding and exercise that we have done. So we will actually try to do more and try to figure out that how actually we can actually automatically, if it's possible, with data to actually identify different kinds of different contexts. There are more examples I think I will skip for this, but they do have important messages to deliver. Here is that existing approach like scenario planning for handling the complicated context, for example, which are based on statistics and probability for dealing with the shallow uncertainty, make the assumptions. So the future events are closely related to the past, which is what we're such as we rely on the historical data, and the cause and effect relationship is sufficiently known, and prediction about the future can be conducted. So, but this assumption is, however, invalid for the complex chaotic Cynefin context, which we enter this deep uncertainty field, simply because we don't hardly or insufficiently know probability distributions of a physical world or highly unpredictable human behaviors, human factors. So we need a different mechanism, in this case, such as closely monitoring how the future evolves and being adaptive over time. So this is the message. So in the future, because now we just have a vision, if I say, so we plan to implement the Cynefin framework for a set of MBSE methodologies to actually demonstrate its cost effectiveness in terms of dealing with different kinds of uncertainties. Thank you. Hope to meet you in the UM workshop. Bye.